That the cause, and in this video we'll be looking at preparation of chloride salt, and this will be the last video under chlorine and its compound. How do you prepare chloride salt? First and foremost, what are chloride salts? Chloride salts are salts binary compound of chlorine, binary salts of chlorine. As you can see, the table is an arrangement of metals in the activity series. So we want to look at the method for preparing the chlorides of this metal: sodium chloride, calcium chloride, magnesium chloride, aluminium chloride, zinc 2 chloride, like that. So we want to see what method will be used for preparation of this chloride. For the sake of potassium, sodium and calcium, you can prepare them by reacting the metal with dilute HCl, or reacting their oxide with dilute HCl, or reacting their hydroxide with dilute HCl, or their carbonates with dilute HCl. Actually, it is dangerous to react the metals with acid because it will lead to explosion. It's a very exothermic and very rigorous reaction. So here we can produce KCl, NaCl, calcium chloride by reacting HCl with their hydroxide, or with their oxide, or with the carbonate salt. In the case of magnesium, aluminium and zinc, we can prepare their chloride by reacting hydrochloric acid with their metals. Since they are not as reactive as potassium, sodium and calcium, it will not give us an explosive or a vigorous reaction. So we can react the metals directly with hydrochloric acid, or the metal oxide with hydrochloric acid, or the metal carbonate with hydrochloric acid. So if you do that, it's going to give us it will give us the chloride of those metals. However, in the case of iron and tin that have ability of forming two type of salt, because they are actually transition element, they have variable oxidation state, so they can form the two chlorides differently. Now in the case of FeCl2 and FeCl3, whenever a metal can form two chloride salts, the one with the lower oxidation number, like the FeCl2, will be formed by reaction with dilute hydrochloric acid, but the one with higher oxidation number can only be formed by reacting the metal directly with chlorine. So that is what you see in the case of FeCl2 and FeCl3. FeCl2 is iron 2 chloride and FeCl3 is iron 3 chloride. Now FeCl2 contains iron in a lower oxidation state, that's +2. So if you want to prepare the FeCl2, you can only do it by reacting iron directly with HCl. That is, you do it by saying Fe plus HCl. This is the one that will give you FeCl2. But if you want to produce the one with the higher oxidation state of iron, you react the iron directly with chlorine. You call it direct combination. It gives you FeCl3. Then you balance the equation by putting 2 here, 3 here and 2 here. So that is how you prepare the salt of a metal that can have variable oxidation number. The higher oxidation number is prepared by direct combination with the second element, while the lower state is prepared by reaction with the acid, that's in this case HCl. The same issue also we have with tin. Tin is also transition in nature and can form 2 chlorides, can form tin 2 chloride and can form tin 4 chloride. Now the tin in tin 2 chloride has an oxygen number of +2, so that's why it's tin 2. So it has a lower oxygen number than the one in tin 4 chloride. So you can guess how you prepare tin 2 chloride by reacting the tin with dilute hydrochloric acid. That gives you tin 2 chloride. But if you want to achieve the higher state of tin with chlorine, you do direct combination with chlorine. Here tin chloride, tin plus chlorine. Here will be tin plus ordinary chlorine. That's when we get tin 4 chloride. You get tin 4 chloride, SnCl4. But to get tin 2 chloride, it will be tin plus hydrochloric acid. That will give you tin 2 chloride plus hydrogen gas. So take note of that. When you know that the metal is transition in nature, to prepare the chloride of the salt, the higher salt, direct combination, the lower, so that's the lower oxygen number, you react it with hydrochloric acid. Now to prepare lead chloride, lead 2 chloride is an insoluble salt. So to prepare all insoluble salts, you use double decomposition method. To prepare all insoluble salts, you use double decomposition method or precipitation method. So what you need to do here is to get a sort of lead that is soluble, that's lead nitrate, and react it with a sort of chlorine that is also soluble. So I use sodium chloride. So you dissolve both of them inside water, so it will be aqueous. So when you do that, there will be double decomposition or precipitation. So the lead will pick up the Cl and give us PbCl2. That gives us PbCl2, and the Na will pick up NO3. So the Na will pick up NO3 and give us NaNO3. Because PbCl2 is an insoluble salt, so it will come out as a precipitate. You call that precipitation method, or if you like, double decomposition method. So any salt whatsoever that is insoluble in water, you prepare them by double decomposition. To know if a salt is insoluble in water, you check your solubility rule. Hydrogen forms hydrogen chloride by direct combination with chlorine. Then here again we have copper in 2 oxygen states, copper 1 and copper 2. Copper 1 chloride is insoluble, so it's prepared by double decomposition. Copper 2 chloride is the only soluble chloride of copper, so you can prepare it either by burning chlorine burning copper inside chlorine, or by reacting copper with copper oxide with dilute HCl. Note that you cannot react copper with dilute HCl because copper cannot displace hydrogen from HCl, but you can react copper oxide, that's CuO. You can react copper oxide, CuO, with HCl. CuO can be reacted with HCl to give you CuCl2 plus water. Or if you have copper carbonate, that's copper 2 triazocarbonate 4 CuCO3 plus HCl, can give you CuCl2 plus water and CO2. So you can use those methods to prepare copper 2 chloride, but you cannot use displacement reaction to prepare copper 2 chloride because copper as a metal cannot displace hydrogen. Mercury can form mercury 1 and mercury 2. Mercury 1 chloride is insoluble, so it go by the way of precipitation or double decomposition. But mercury 2 chloride can be prepared by direct combination of mercury and chlorine. So burn mercury gas inside mercury metal inside chlorine gas, it gives you mercury 2 chloride. Then for silver, Silver chloride is an insoluble salt, so you prepare silver chloride by double decomposition, or if you like, by precipitation. Don't forget that in double decomposition you get the salt of the metal that is soluble and the salt of chlorine that is soluble. Dissolve them in water separately and mix them. Then the compound you are looking for will come out as a precipitate. That is what you call double decomposition. You mix aqueous solutions of the salt of the two elements together to give you the precipitate. Then finally, gold. You prepare gold 3 chloride by burning the gold directly inside chlorine. You call that direct combination with gold. So this is how you prepare this salt, chloride salt. How do you test for chloride ion? There are 2 reagents to test for chloride ion. Number 1 is acidified silver nitrate, or if you like, acidified silver triosonitrate 5. And you can also use acidified lead nitrate. So first and foremost, using acidified silver nitrate, when you add the salt, the solution of the unknown salt, into acidified silver nitrate solution, you acidify a solution to prevent precipitation of unwanted ions. So you don't want ions you are not testing for to precipitate, so that's why you acidify the solution. It will remove all unwanted ions. All right, so that's why when you add an unknown salt into a solution of acidified AgNO3, if it gives you a white precipitate, as you are seeing in this on your screen, it shows that it's possible that chloride ion is present. To confirm it, add ammonia solution to that precipitate. If it dissolves and give you this colorless solution, then chloride ion is confirmed. You can also use acidified PbNO3 to test for the presence of chloride ion. When you add the unknown solution into PbNO3 and it gives you a white precipitate like the one we are seeing in this place, it's a sign that chloride ion might be present. To confirm that it's chloride ion, using PbNO3, you are going to heat the precipitate. You heat it like this, you heat it and allow it to become hot. Now if the ion is chloride ion, the precipitate will disappear on heating, or if you like, it will dissolve on heating, and when you allow it to cool down, the precipitate will reappear on cooling. So when you get a white precipitate with lead nitrate which disappears on heating and reappears on cooling, then that means the unknown salt contains chloride ion. So these are the 2 methods you normally use to test for chloride ion, or to test for ionic chloride. You can to test for ionic chloride, or test for chloride ion, or test for soluble chloride. So it's all the same thing. Acidified AgNO3 will give you white precipitate soluble in aqueous ammonia, or with acidified PbNO3 it gives you white precipitate that disappears on heating and reappears on cooling. So this is how you test for chloride ion. When you heat a solution of hydrochloric acid, when you heat it, the hydrochloric acid solution will boil to liberate hydrogen chloride gas and lose water. Normally, in the first place, water will be leaving. So that will lead to an increase in the concentration of the HCl solution. So when you keep eating for a long time, the eating will no longer have any effect on the concentration of the solution. So when you have a solution that now has a constant boiling mixture, that is the one whose heating no longer affect the concentration of the solution, you call that azeotropic mixture. So hydrochloric acid forms azeotropic mixture with water at 22.2% concentration. So if you have to define azeotropic mixture, is a constant boiling mixture of liquid which cannot be separated by further boiling or by distillation. You call that azeotropic mixture, and you call the mixture azeotropes. So azeotropes are constant boiling mixtures that cannot be separated by further boiling or by distillation method. So this is the end of halogens. God bless you. Amen.